You can think of it like something similar to Agents MD or Cloud MD, but something more powerful. Something about the tooling landscape, I wouldn't focus on given tools, but I group them into some areas. And I would like to share my best practices with you. Hello, my name is Paweł Kmiecik. I work as Senior Staff Machine Learning Engineer at DeepSense AI. And today I'm going to tell you something about specification-driven development. So let's start with the agenda for today. First, I try to define the problem with vibe coding. Then I tell you about the spec-driven development, how it works, what it is. Then we'll go to benefits, drawbacks, my recommendations, and where to start. So why SDD? Maybe some short introduction. So I see that teams produce code faster, but they create software slower. And the spec-driven development tries to mitigate this issue and tries to solve the most common issues with the vibe coding. Yeah, maybe something about the Gen AI revolution. So we can say for now that the most hottest new programming language is English. That's the statement from Andrej Karpathy in 2023. And 3 years later, we see the environment, our environment looks like. So most of us use AI tools, and some startups are even generating almost all the code they create. So it looks like the English is now the most commonly used language while programming, but we shouldn't forget that it's not replacing the software development. So the hard part, like deciding what to build, what done looks like, it's still be there and will be for next decades, I think. So for the vibe coding and why do we have a problem with that? Maybe some of you don't think that there is any problem with vibe coding, but in my opinion, it's a great tool for quick prototypes, some scripts, and fast POCs. But from my experience, it breaks down at scale. So if we want to create something for production, we have some examinations that show that, well, just vibe coding makes the quality of the code worse and worse. And well, this is not the problem with AI tools that we use, but this is the problem how we use them. So the AI did exactly what it was asked to, but what it was asked kept changing over time. So going to the spec-driven development, we should start with the specification and its definition. I can say that, generally speaking, any please implement prompt you write down to your AI agent or AI assistant is some kind of a specification, just a really low quality. And for specification, we have some formalized languages like EARS or Gherkin or RFC 2119, which tell us how to create a good, precise specifications. You may know it from, for example, behavioral-driven development. For the spec-driven development and what is the status of this field for now, we can say we have like 3 approaches to that. First is spec first, and this is when we just prompt our AI assistant. Some kind of specification is created to perform a given task, but when it's done, when our code is generated, then this specification is like thrown away. It's not used or committed to the repository. Then we have spec anchored, when we keep both specification in our repository and also, of course, the code generated, and we try to keep them in sync. And the last one is spec as source. So we only care about the specification and we treat the code generated like compiled binaries. So in practice, most of the teams do the first one. The spec as source is still something aspirational, so it doesn't work yet. And most of the spec-driven tools that I will show you, they are something in the middle, so like spec anchored. About the workflows and the how the spec-driven development tools define them. They differ somehow. So, for example, SpecKit from GitHub operates on constitution, specify plans, tasks, and implementation. For Cairo or OpenSpec, the workflow looks a bit different, but from my perspective, it's mainly about the names, but the fundamentals keep the same. So most of these tools use something similar to a project memory bank. So this is the context that will be used for implementation phase or planning phase. That applies to all the features that we develop, not only a current one we are specifying. The naming, as you see, is different, and you can think of it like something similar to Agents MD or Clock MD, but something more powerful because it's built into the given tool. So the enforcement is higher than the config files I mentioned. So you can for example put like your preferences for tech stack or the security and the most important things to you during the development. And how this workflow looks like when you go to implementation on a given feature. So first thing, and the most important thing you should focus on, is the specification. So I'm going with the SpecKit nomenclature. So first command is specify, and well, we can start with something what you see on the left, but most of the tool will create something what you see on the right. So something more strict and formal in language. And this is the thing, the artifacts that the given tool will create to you or generate for you, that you should review manually. That's something important, because basing on that, on the specification, it will just create or generate the plan and implementation for you. That's why this is after the specification is generated, you should focus on reviewing it and correcting before the next steps. Next items, let's say, in the workflow are most commonly plan and tasks. So for a given specification, a given, let's say, scenario, a plan is being generated. So it's broken down into smaller pieces and more precise parts. So research or some API contracts, etc. Then it's even the granularity is even higher with the tasks when it's broken down into single tasks. Some of the tools can perform these tasks in parallel. It's not so important because the whole thing is just generation, so it will take like 20 minutes to give you a working feature. And the last part is the implementation. And again, I wouldn't spend much time here because, well, it's just generating code, what you probably know from AI assistants that you know. But all the things that I mentioned before are injected into context and also steered by a given spec-driven development harness or tool. It's the enforcements are higher than in standard vibe coding. So your job here, it shifts from typing the code to reviewing the code. So, well, still we have specifications, but reviewing the code, we don't have for now an approach that fully replaces human being from that part. And something about the tooling landscape, I wouldn't focus on given tools, but I group them into some areas, let's say. So first group is the dedicated spec-driven development platforms or tools. Then we have lightweight frameworks and methodologies. So these are more like manifests or of how you should use your AI assistants. Then we have agent native things, so you can create spec-driven workflows using, for example, Cloud skills. And just DIY, so create specifications, put them in docs folder, and reference them from Agents MD. might work in many cases, maybe the simpler ones. So for benefits, first, the intent fidelity. So when we have the artifact as of a specification, the intent is clear. You can even show it to someone else, not just during. It's not forgotten during your AI assistant session. So you can and you should review the specifications before next parts. This is probably the part which we skip during just vibe coding. What also is nice is that the context survives. So we don't need to carry about the sessions and plans that we create during vibe coding. The context survives because we have the specification files committed in our repository. Team alignment is also something additional, so additional benefit. If we have a new hire in our team, or we want to show or assess the specification with someone outside our team, we have the specification written down. We can show it to someone, and of course, they are also used for implementation by AI agents. And now pivots are cheap because, well, if the specification changes, we just regenerate based on that. But the drawbacks, well, if you start using these spec-driven development tools, you notice that the number of Markdown files grows really fast. And all these files are additional text that you need to review. Yeah, so there is additional overload. Also, as I mentioned, the workflows are not standardized yet. So there are different approaches created by different tools, and well, you can quickly go into some maybe not a trap, but I've observed some tools that were not developed anymore, and then you need to switch to something else, which might be much different. We also have a problem of spec drift. So while we have even precise specifications, still non-deterministic LLMs can ignore what we are telling them or our tools are telling them, and the generated code and the specifications can just diverge. And well, most of the tools that I use work nice in greenfield projects, but they are not so good in brownfield projects. So if you would like to start in the middle of the project, some of tools might not even allow that, but not all of them. So there is also the question, well, if we have the specification of everything, of every feature of the whole project, isn't that just a waterfall? Well, the answer is, well, it is somehow, because we have the requirements gathered, then we plan the tasks and we implement. But the iteration loop is much faster, so it's not taking a year like in some ancient projects. But now it's more, we can measure it in minutes or hours maybe. So we still can iterate fast if we pick the right tool for that. And I would like to share my best practices with you. So you should avoid using SDD for trivial tasks. And this is the recommendation that you probably will find on the net. Until you just want to learn a given tool, you can start small. And also what is important is to keep the general memory of the tool. So for example, for spec kit from GitHub, it will be the constitution. First, you should take a close look into what you put there. And also you should evaluate if what you put there makes any difference. Because, well, if you put there some things that doesn't make a change, then it's only a noise in the context. Second thing is the spec authorship and specificity. So I recommend creating some specifications manually at first, using maybe Gherkin or RFC 2119 language to be just better to exercise in that. Then you can switch to You can switch to, for example, OpenSpec or SpecKit, which will create that for you. But you should create a skill in yourself that will help you also reviewing the specifications created by the AI. And you should also always verify the specification files and plan and tasks files as well before hitting implementation, because if you will make a mistake there, the code generated might be just a trash sometimes, and you will just waste time and tokens. After the point 2, when you will be just good in creating specifications, you shouldn't edit them manually. Why is that? Because if you chat with the AI assistant on a given specification, it can find some more ambiguities than you will find. So it's good to cooperate with AI assistants in creating and editing the specifications as well. Most of the tools have something additional to standard workflow that help you with that. And the last thing is you should share your specifications with managers or maybe with your product owner, just to check if it is readable by a normal standard human being. And it's also worth remembering that specifications were meant to close the gap between the business and the engineering. And you probably know this approach, from example, from behavioral-driven development, when similar specifications are created. So key takeaways from today. Now we see that the bottleneck moved. We no longer type code, but we describe the intent precisely. More precisely, then the results are better. Now this specification is becoming the source of truth. Maybe you are in the middle of this process, but we can treat the code generated as maybe not yet as artifact or like a compiled binary, but something which can be easily modified by AI. What is important? Specs survive across agents and sessions. No more context decay. And what I recommend to you as a starting point, create your ears language specification manually first, then check some dedicated tool. From my experience, OpenSpec seems to be the most flexible for now, because you can start even in the middle of your project. So that's the takeaways from my presentation. If you liked this content, please hit the like button and don't forget to subscribe our channel, share the video, and if you have any questions or thoughts, don't hesitate to comment. So thank you very much for today. Bye.